Hi, my name is John Melbourne, Principal Risk Management Surveyor at Ecclesiastical Insurance. I'd like to welcome you to this short presentation on common cladding system construction methods in the context of contemporary/modern methods of construction. The use of cladding systems in modern buildings has grown in recent years, and I'd like to highlight some of the key drivers to this. A recent report by the Royal Institute of British Architects estimated that the speed and cost of using modern methods of construction can be anything up to 60% faster and 40% cheaper to build. Many new buildings incorporate off-site factory-built sections, which enable better quality control during the manufacturing stage. Recently, there's been a decline in skilled construction workers in the UK. Both Brexit and COVID have impacted this. This means modern methods of construction is seen as advantageous, as using off-site construction processes requires less skills and fewer people to assemble once on site. The review of Part L of the building regulations in 2006 led to more focused guidance on the conservation of fuel and power in buildings. This has led to an increase in insulation of buildings. And the Carbon Zero Challenge has seen an increase in the use of insulated cladding systems as a means to improving the thermal performance of buildings. The UK government is also actively backing the use of modern methods of construction in many documents, including white papers on planning and school framework adoption methods for modern methods of construction. Let's have a look at some of the common cladding systems in use today. External thermal insulated cladding systems, or ETICS as it's commonly referred, is a built-up proprietary wall cladding system. It's a way of adding an insulation layer and a coating to the exterior of a new or existing building, and typically comprises an external facing of weather-resistant render of around 3 to 5 millimeters in thickness. This is applied over a metal reinforcing mesh substrate, which in turn is overlaid a substantial layer of insulation material. This is then all attached and bonded directly to the walling of a building, which may be solid brick, concrete, timber, or a lining board on a steel or timber frame. There are a number of aspects relating to ETICS which insurers have to consider. Firstly, it may look like stone or masonry, and therefore there's a risk of false identification. The surface to which the system can be fixed varies, so we need to understand the whole wall build-up to determine the fire performance. Different types of insulation materials, from non-combustible mineral wool through to combustible foam-based materials such as polyurethane, polyisocyanurate, and even polystyrene can be used. Surface penetrations in the wall systems can expose the insulation core. This is critical where combustible insulation materials have been used, so fire stopping of the penetrations is therefore essential. Some of the major manufacturers of ETICS systems in the UK include Baumit, Permarock, SBS EnviroWall, and Stotherm. Another popular cladding system are high-pressure laminate panels, or HPL as they're commonly referred. These are decorative cladding panels, typically of around 6 millimeters in thickness. They're made up from layers of wood-based fibres, which are sandwiched between two surface layers. These are bonded together using heat and pressure to form a panel. These panels are then fixed to a supporting aluminium or timber frame to form a decorative external finish to a building. HPL panels come in standard and fire retardant forms. From an insurer's perspective, the fire retardant panels are preferred. However, even these are still classified as being of limited combustibility rather than non-combustible, and can have an impact on the insurability of the building. Major manufacturers of HPL panels in the UK include Trespa and Vivex. Another form of cladding system is rain screen cladding. Rain screen cladding is an outer skin of ventilated cladding applied to a new or existing building. It consists of an outer panel, a ventilated cavity, insulation layer, and an inner leaf of walling. The outer panel, or the facade as it is called, can be of almost any finish: brick slips, ceramic tiles, reconstituted stone boards, high-pressure laminates, glass, composite metal materials, fibre, cement boards, and wood can be used. These panels are fixed and supported on a subframe, which is called a carrier, which is then fixed to the wall of the building. Between the panel and the wall of the building is a cavity, usually a 50 millimeter air gap and enough space to include insulation. The carrier system is fixed through the insulation to the backing wall. The backing wall can be of masonry, brickwork, steel or timber or any material providing the structural framework of a building. An issue for insurers is the identification of the fire loading on the structure. Identification of the materials, both the external panel and insulation layer, and their fire rating and performance is therefore critical. The presence of the air gap creates a chimney effect and has the potential to intensify any fire. Rain-skin cladding is also open at the base to allow moisture to drain, but this also gives ready access to the insulation layer from a potential fire. Cavity barriers at each floor and compartment level reduce the risk of fire spread. So some of the key considerations if you're thinking about cladding systems. What could be the extent of the fire damage? How can the performance be improved with fire stopping, fire breaks, compartmentation? What's the fire and rescue service response going to be? Many fire and rescue services will take a bespoke approach to cladding systems constructed from combustible materials. And once occupants have been accounted for, they may well not commit to trying to save the building. How easy is it to repair a damaged or charred section? Can it simply be cut out and replaced? Or will there be a need for dismantling undamaged sections of a building to effect the repair? How susceptible is the cladding system choice to water damage? Will it require replacement, which can impact both repair costs and business continuity in the event of a modest escape of water? As an insurer, we accept the need to embrace carbon zero and sustainability, but we do have concerns about the amount of combustible materials being used in contemporary buildings and their resilience to the effects of fire. We would therefore encourage early engagement with your insurer on any building or sustainability project, as whilst the project may comply with published guidance, it may not necessarily satisfy your insurer's requirements and could impact the insurability and the cost to insure the building for its design lifetime. At Ecclesiastical, we have a dedicated team of risk management surveyors who have a wide knowledge of contemporary construction methods and are available to discuss any projects you may be planning, so please do get in touch. Thank you.